G'day. Welcome to the next one of these. We have a pretty big problem that I want to talk to you about. These happen not irregularly, these happen sometimes, and it's not really the biggest problem. However, we want to be rigorous with our science, right? It's something that's important to me, and hopefully it's important to you. And there's an issue with the rigor of the previous code. Let's go and have a look, and I'll explain exactly what it is. So let me just grab any one of these models. Here we have a mean split model of the Glasgow norms. The code here from here to here. This is creating the column for the categorical dependent variable that we use for classification. Now, we don't have to use a categorical dependent variable. We could set these models up for regression. However, one of the things that I like about these machine learning algorithms is their interpretability, and we get interpretability through classification accuracy rather than giving an effect size for each of the features using regression. Anyway, we do what's called a mean split. And the problem with doing a mean split is that while it's pretty good, it's not a perfect way of getting balanced data sets. So what we really want with our data set is we want to have the exact same number in each of samples in each category. Now, this shouldn't be too big of a problem for the Glasgow norms, but if we go and take a look at the NRC data set, we can see here, this is mostly comprised of null values. I've done a count here, all instances of 0, all instances of 1, and we can see that it's a 9-to-1 distribution of null values to values of 1 for the anger variable in the NRC dataset. Let's go zoom in a little bit. All right. So, well, what kind of effect is this going to have on an XGBoost algorithm? Is the algorithm going to overpredict to that null category because it understands that about 90% of the samples are null? Well, we can test that. Here I have the NRC variable from the NRC data. I have the NRC variable anger. We know that this occurs at about 10% in the data set. So a naive model that was just classifying according to the majority category would achieve an accuracy of 90%. If I run this script, and I have to reload pretty much everything. Give me half a moment. Run that. Run the k-fold process, and then construct the model. Now this should take about 30 seconds. Train control not found because I have to go back and do the train control and the grid tune. Okay, now this should take about 30 seconds, so long as I haven't forgotten to run another line of code. All right, so this will take about 30 seconds to construct the model. Then what we're going to do is we're going to take the testing subset of the data, feed it back into the model, and have the model explain to us exactly how accurate it is. Now, I should note that while this is going, the accuracy for the Glasgow norms, depending on the psycholinguistic domain, is somewhere between 60 and 65%, where domains like size, concreteness, imaginability seem to be really quite robustly reflected in American English, where the other ones are a little bit less robustly reflected, but still pretty good, right? Like a 60% might not seem like a lot, but when you consider that we're constructing these models using phonemes and phonemes alone, we're not talking about biphones, we're not talking about morphemes or words. These are simply built on phonemes. That's a pretty accurate model, I think. You might disagree. All right, let's take a look at our confusion matrix. And wowee, we have an accuracy of 90%, right? Now you might be thinking, why aren't you jumping for joy? We can take a look at the confusion matrix and we can see that the model is over predicting to the null value. Okay, so this is a problem. We have an issue here. It's more than like it's over predicting more than 90%, right? So it's like the most important thing that it's taking into account here is the distribution, right? The uneven sample size. Back to the Glasgow norms. Why is this a problem? Because mean split is not going to give you exactly equal sample size. Okay, so I already knew that this would be an issue for the NRC data set, but for the Glasgow norms, I thought that mean split was probably good enough, but scientific rigor, right? Good, probably good enough, probably isn't good enough. We want to be as rigorous as we can. We want to present as fair a model as we can. And one of the things that's kind of interesting about this research is that, especially in sound symbolism, is that you get these really kind of interesting uneven distribution, like the way that the model categorizes. So this is the arousal data set, right? And we see here that this is the unarousing, remembering that we're dealing with a two-tailed data set. This is the unarousing prediction. And you can see that it's really heavily preferencing that, right? Now, given that this is a pretty balanced data set using a mean split, we can ascertain that it's over predicting to the unarousing category based on something going on in that data. There's something interesting going on in that data. This is something that I'm possibly partially obsessed with at the moment to try and figure out exactly what's going on here. Let's see. Here we have it again, but for valence, where a low score is negative and a high score is positive, it's over predicting to that positive category. So there is it positive or negative? I have to go back and look. Anyway, it's over predicting to one of those categories. I'm not sure why it's doing that. I'd really love to explore that in this data set, but we can't do that using mean split because mean split will give you uneven sample, sample categories, right? So what does that mean? It means that I get to spend my morning rebuilding this code, which is not exactly how I want to spend the morning, but this happens. It's just something that's going to happen. If you get into machine learning, you're going to make the tiniest of tiny mistakes that probably has no influence on the model output, or no major influence on the model output, but long elongated sigh followed by scientific rigor is important. Some speech along those lines. Anyway, I'm sure that if you feed that prompt into ChatGPT, it will give you a nice speech about scientific rigor. Me, I'm busy. I've got to go and rebuild these models. All right. Take it easy. I will get back to you once these are built, and then we can start reporting on the accuracy and the feature importance. All right. Take care.